Okay, so let's move forward. We're going to go back now to our eyelash example. Here we go. So now that we have some terms and ideas and words that we can use to describe what's going on here, let's take a moment to describe this particular plot in terms of these three basic characteristics. So again, what you're seeing ideally here as you're looking at this is that we do have a linear form. So we can imagine a line going through the points, and the points are clustering around the line. I'm hoping you're seeing that we have this positive slant to our line, so we have a positive direction. And then in terms of strength, how would you talk about the strength here? So sometimes it's hard to really know for sure. Is it more of a moderate relationship? Is it a strong relationship? Is it closer to being weak? This can be somewhat subjective when you're just looking at a scatter plot. I would say here, though, that we have a strong relationship. You could possibly say it's moderate to strong, so sometimes we use those types of words to describe what's going on here. But obviously there's a pattern here. The points aren't terribly far away from the line. So there's a positive, linear, strong relationship. And just a few other examples of scatter plots. I always like it when I see scatter plots in the news, and this was kind of an interesting plot that I saw in the New York Times not terribly long ago. So, do you think that nutritionists and the public agree on what constitutes a healthy food item? So, a lot of you, I'm sure, like to eat healthy foods, and you're trying to decide what's healthy and what's not. Do you think you're good at choosing healthy foods? So there was a study done. They had 52 different food items, and they basically asked a group of nutritionists to look at each item and indicate whether they felt the item was healthy or not. And then for each item, they looked at the percentage of nutritionists who said the item was healthy. And then they did the same thing with some American voters. They had a sample of American voters. They asked them to go through the 52 food items to indicate if they thought they were healthy or not. And then they looked at the percentage of Americans who thought those items were healthy. And here's what we ended up seeing. So here's what the scatter plot looks like. On the x-axis here, we have the percentage of nutritionists who say the item is healthy. On the y-axis, we say that we have the percentage of Americans who think the items are healthy. And what you can see here is that there does tend to be a good amount of agreement. So, as the percentages get higher for Americans, they get higher for nutritionists. So, for example, if we look up here, there are certain items like there are lots of vegetables and fruits, and chicken is up here. So a large percentage of Americans think those particular items are healthy, and a large percentage of nutritionists also think those items are healthy. Down here, there are French fries and cookies and soda. So a small percentage of Americans think those items are healthy. A small percentage of nutritionists think those items are healthy. So within this plot, each food item is represented with a different symbol. Some things do jump out, though, that are a little bit different from the pattern. So you might notice over here, for example, that there are certain items that the American public tends to think are more healthy. Things like frozen yogurt, coconut oil, granola bars, granola. So these were rated kind of more highly by Americans as being healthy. But nutritionists, don't really think they're as healthy. So a smaller percentage of nutritionists were saying that those items were healthy. There are some other things kind of up here that you can see. Something like sushi, for example, tofu. So those are things that the American public, not so much, maybe about half of them think that those are healthy items, but nutritionists are more likely to say that those are healthy items. So as we look more carefully at these plots, we can see certain points that kind of deviate a little bit from the pattern and other points that go along with the pattern. But overall, what we're seeing is a positive linear relationship and a fairly strong relationship, moderate to strong maybe. Here's another, and if anyone wants to look at this in a little bit more detail, here's a link to the actual article about it. When you fall in love, this is what Facebook sees. I'm not really sure if Facebook is as popular as it once was, but some researchers did a study where they looked at relationship statuses and timeline posts to see if there was some kind of relationship. Here's what they found. So they were looking at along the x-axis, you can see that it was the days before and after a relationship starts. On the y-axis is the average number of timeline posts, and you can see that it's not a linear relationship. That kind of we have this increase in posts as someone's getting ready to be in a relationship. Maybe they have their eye on someone. All of a sudden, the relationship begins, and you clearly have other things to do. You don't want to be spending your time on Facebook. So this clearly is not a linear relationship, but we can still look at it by using a scatter plot. So again, sometimes you'll actually see scatter plots in the news. Okay, so here's another just quick relationship I wanted us to look at, and then we'll go back and look at our eyelash data in a little bit more detail. But let's say you want to look at the relationship between the time the average person in a given country spends eating and the country's obesity rate. So maybe I want you to think about, before we actually see the relationship here, what you would expect the relationship to look like here. So would the obesity rate be higher the more time that is spent eating? Would it be lower? Would there maybe not be a relationship at all? Here's what we actually see. And again, each point here is a different country. So here, if you had to describe the relationship, what would you say? So remember what those three key things are. So there is a line that goes through the points. So we would say it's linear. The direction is something we'd want to comment on, and here we have a negative direction. So here, actually, as the minutes spent eating per day increases, the obesity rate goes down, which is maybe a little bit different from what we would expect, but obviously what you're eating is going to make a difference. The types of foods in different countries, the calories, the fat in those foods, lots of things are going to come into play here that are not being taken into account looking at the scatter plot. And I would say maybe it's more of a moderate relationship. So we do see, a fair amount of scatter around the line here. But there is certainly something going on here. Okay, so let's go back to the eyelash example. So we've been talking about the plot and what the plot will tell us, what the scatter plot tells us. We're going to go a step further now and compute what's called a correlation coefficient. So when you see the symbol R, that stands for correlation coefficient. And there are two things that a correlation coefficient will tell you. A correlation will tell you something about the strength of the relationship and the direction of the relationship. So in front of the coefficient here, if there's a negative sign, we know that the direction would be negative. If there's no sign at all, we know there's a positive relationship. The actual number tells you something about strength. So we can see something about direction and strength by looking at a correlation coefficient. But if you're just given a correlation coefficient and you are not given a scatter plot to look at, we have no idea if the relationship is linear or not. So the correlation coefficient is something you can compute no matter what kind of relationship you have. But it's only going to be meaningful to interpret in a particular way if we know the relationship is linear. So keep that in mind. Just looking at a value of R, you would have no idea whether the relationship is linear or not. But it has to be linear in order for you to properly interpret R. Okay, so in terms of understanding some terminology that you're reading about in Chapter 14, sometimes we talk about an association between two variables, x and y. So we usually use x and y to stand for our variables, and that just means that there's some kind of relationship between those variables. We want to be careful, however, in terms of concluding that one variable causes the other simply because there's an association. So association does not mean causation. A big thing that you'll hear us talk about all the time is that correlation does not imply causation. So simply because two variables seem to change together or have some kind of relationship, we need to be very careful in terms of when we can say with any certainty that one must be causing the other. And we'll talk more about that soon. So the correlation, or R, so a lowercase r is our symbol for the correlation coefficient. This again is this numerical description of the relationship, and it tells us something about the strength and direction of that relationship. Oops, sorry about that. And as you might remember back when we were talking about chapters 5 and 6, when the variable that we call x, we tend to call that an explanatory variable, or sometimes it's called an independent variable, especially in the context of experiments. So notice that we have an x in explanatory, an x here, and then the y would be our response variable. And this becomes more important when we get into regression, when we're trying to predict one variable based on another. So what we're predicting is the response. What we're using to make the prediction is the explanatory variable. Okay, so there are several really important correlation facts that we want you to know about. And actually, before I kind of get into these, this might be a good place to pause this video, and then we'll come back later because I don't really want to rush through these. These are really, again, very useful, very important. Having a good understanding of these different facts will help you be able to solve lots of different kinds of problems. So let's pause here and we'll come right back to this.